Hi, I'm Cloud Solution Architect Phil Jersa. The following video is a recording of a recent code review highlighting some of the major upgrades coming to Project Graphir. First, I give an overview of the project to a couple of new developers on the Emerging Opportunities team. Then, I highlight how we've simplified the project structure while solving the problem of loading referenced FHIR resources by using generic data loaders and resolvers. Finally, I give a live coded demo of how to implement additional FHIR resource types.
Okay, so this is going to be a code review for our project Graphir. We have a cool little slide deck that kind of gives the business value, the reason why we created the project that Samir can share. But from a developer's perspective, kind of all you need to know about it is that we wanted to create a GraphQL interface over a FHIR RESTful API. So in our case, the Azure API for FHIR and the Azure Health Data Services FHIR API don't support the GraphQL endpoints natively, which is part of the spec, but we just don't support them currently. So we wanted to create sort of a starter kit or project that would demonstrate how you could write your own lightweight proxy in front of one of those two services in order to provide this GraphQL interface. So I can show you what we have today. Currently, if you go to aka.ms/Graphir, it will load this GraphQL Playground or editor interface. We're using a .NET framework for GraphQL called Hot Chocolate. That's how we wrote the interface for this. And Hot Chocolate has a tool called Banana Cake Pop. So if you're familiar with like Apollo, GraphQL and stuff, they've kind of got their own interface or playground. This is the Hot Chocolate equivalent of that. So it's a little tool called Banana Cake Pop, where you can write some queries and test it out and see what your results are. So I signed in just a minute ago before the meeting started. The way that GraphQL works is basically it's an API endpoint that you submit post requests to in the shape of either a query or a mutation. And so this, I've got a bunch of different examples on the screen here, different requests. But so like lines 1 through 6 would be an example of a post body that you would send to that API endpoint. And you define, you have to have, based on the schema language or the schema definition, you would have different types of queries and mutations defined. So you tell it, here's the name of the query I want to execute. And then when that data returns, you can tell it, here are the properties that I want you to return. So you get the opportunity to like shape your own response from the API. So that's kind of the power of it. And one of the primary reasons why we wrote it is because if you look at just straight up, like this is an example of calling into a FHIR API, right? Like you just get these massive like JSON nested objects back that are, would be a nightmare to have to deal with and write like DTOs over them for, say, a client-side app or like a mobile app or whatever. So it'd be much easier if we could use a GraphQL interface and just say, hey, I only want like the patient's first name, last name, and who their primary physician is or whatever. And then it also does some work too with building out trees of information. So if you have, for example, resources where it might have a link or a reference to another resource, typically in the response from the FHIR API, what you get is just a string URI link that says, hey, here's where you would go look up the additional information for this referenced resource. But with GraphQL, the intent is like all of that's built into like an object tree, and you would get all those objects returned at the same time. So you don't have to keep making like multiple requests to go fetch additional information. So, this is pretty straightforward. You can see like I executed this. I said, hey, I want the patient list from their name. Give me their given name, which would be like their first name, and then also their family name. So you can see that name is a collection of names. A patient could have multiple names in their record. They could also have multiple given names. So the example there is in a patient's record in FHIR, usually you would have their first name and their middle name, and then maybe like aliases would be listed in their given name collection, and then their family name or last name. So that's just an example of what the data payload looks like there. Let's see if there's something else worth looking at here. It's kind of nice in the editor too. Like if I say query and I say just a demo is the name of the query. We'll call practitioner again. You can see that this is a specific getter, so I need to give it, it's giving me all this IntelliSense is kind of the point I'm getting after here. So like we need to put in the ID of the resource we're looking for. You can hit like Control Spacebar and it gives you a list of, based on the schema definition document that's being returned to the editor, here's all the properties that are available to you, and you can use that to build up your queries. So pretty handy little tool. And then obviously you would, once you define what your queries are, you'd take those and then bake them into like your client-side app or whatever you're going to use to pull that data and display it to your end users. Okay, so that's just a super high level of GraphQL, the Graphir project, kind of why we built it from a developer perspective and what we're trying to do. So one of the changes, this is a code review. I made a ton of big, like lots and lots of changes over the weekend. The first big change I made, I'm going to show you the repo. Chad and DG, you guys both should have access to this. But if we kind of look at the folder structure here, when we first built this, it was like an MVP project. We said we're only going to build out 2 resource types, that is the patient and the practitioner, because patient includes a reference to who their general practitioner is. So we just wanted to show like, hey, here's how you would implement like a GraphQL schema for these 2 resource types, and like how you could build the relationship between the patient and the practitioner. So that was kind of our original intent. The project has recently gained a lot of attention by Microsoft customers who are using API for FHIR and want to use GraphQL. Like this project is kind of the only game in town, so a lot of people are looking at it recently. There's also a group in Qatar that has been contributing a ton of additional resources to the project and like helping kind of build it up. So that's been really cool to see that like we're getting some open source community involvement in it. They're doing a great job with like the PRs and documenting things and so forth. But if we look at the structure here, the way it started off was that we had basically a folder in the repo for every resource type in FHIR, right? So if I go and look at, I've got a sample API that's out on the internet here called HappyFHIR, and I'm using that because they've got a bunch of sample data I can access pretty easily. But like here's a list of all the resource types that are available, right? So we kind of started to notice with the project that like, hey, if we create a folder for every single one of these resource types, like this project is going to be super annoying to look at. Like, is there a way to reduce the number of folders there? So that's one thing I looked at doing, and we'll see that in a second, but this is the way it exists today. If you start looking into these folders for each resource, you see, patient has this thing called the, patient by ID data loader, and then it has a class for mutations and a class for queries. Okay, so if I go to practitioners, oh, look at that. It's got a practitioner by ID data loader, a mutations class, and a query class. Like every single one of these folders has the same 3 classes in it. So I wanted to find a way to consolidate all that down and like make it so that we don't have to have a new folder for every resource type that gets implemented. Okay, so before I show how we did that, I want to address basically the problem statement that came to us via an issue from the team in Qatar was when you have a reference to another resource, the way that those can be defined in the FHIR specification is like it just says it's a like resource link and then a list of resources that you could link to. and it's always a different number of resources or a different list of possible resources. So like an example here, if I look in the FHIR spec, this is for just a very basic resource type called group. And you can see that here in the like managing entity, for example, is a reference. Maybe I can zoom in a little bit on that for the video. And you can see that the reference could be to any one of these other resources: organization, related person, practitioner role. Okay, that's great. Like, what if I go to a different resource, like medication, for example? I'm just like kind of randomly picking some other ones here. So inside of medication, you have ingredients. Ingredients have items, and items could have a reference. And it's kind of defined the same way, right? It's a reference type, but now it's to these different objects. So basically what they're asking is like, well, how do we write our GraphQL schema? How do we implement this so that we can create a reference to sort of a predetermined or predefined set of other resource types? And the way that we had originally designed Graphir was, again, it was just those two resource types, patient and practitioner, where patient has a reference to practitioner, and we just kind of fudged it, right? We said, oh, like we know that the practitioner link is most likely always going to be a link to the person's practitioner resource. We'll just have it always look up and assume that it's going to be a link to that resource type and then return that resource in the response. So if I go back to Banana Cake Pop over here, and I look at this, I can say like, oh, give me their general practitioner, tell me their name, family name of the general practitioner. So now if I run that, we'll find not a lot of our sample records have them, but so here's one where we've got a patient, that's their name, and then, oops, sorry, keep going. Here's one with general practitioner. So that's how it would show up then, right? It basically gets returned as that resource type nested inside of the patient record that gets returned from Graphir. But that's problematic because now what if it was going to return, for example, if I go look at the patient definition of FHIR, oops, clicked on the wrong one. If I look at their general practitioner reference, it could actually be a reference to any one of these three things. And we just sort of made the assumption that it was always going to be a reference to practitioner. So that is the problem statement. And that's how this whole giant snowball started of me making a bunch of changes, was how do we solve this problem of returning a predefined set of resource references? Does that make sense so far?
No, I think that makes sense. Is there anything to identify whether it's a practitioner or a...
Yes, exactly. There is. So let's go look at an example of that, and that will clue you in as to how I solve this as well. So if I go to, let's see if I can do this. Again, I'm going to hit this other publicly available sample FHIR API just because they have way more data and a lot more examples built out than what we have in our sample data set.
It's also the standard example set that everyone uses.
So I'll do patient, and then I'll say like general practitioner. Oh, I thought that would have, there we go. So I'm putting a query statement in here to say only return patient records where the general practitioner has a value, basically. So when it's missing, or where missing equals false, just basically meaning that element needs to contain data. So we'll run that. And of course, I did something wrong. I thought I ran this earlier. Hold on. Spelling counts too when you're doing this, so that's probably why it didn't work. That is very small type. Okay. Here we go. So now these are all patients that have a general practitioner. So if we look at this, you can see in the reference that comes back from general practitioner, the reference link is a relative link to another resource in this system. And then it usually has a display name. So what we're trying to do is like, oh, let's, grab that element or that resource based on the relative reference link and return it. But the problem is, as we just saw in the spec, this could also be organization or whatever it was, like practitioner role or something like that. You've got all these different options for what type of data that is. But the point is, if we can somehow like inspect that reference link when we're doing the lookup to grab the data, we can tell then which type of resource we're going after and use that to craft the correct query then to the backend FHIR API. So that's what I tried to do. The first problem I solved was how to tell this, like the definition for these properties where it's a reference to a list of resource types, how to like generate the correct schema for that, how to get it to return that information. So we're gonna dive into the code, and sorry, this is probably gonna get like real nuts real fast here. But let's say I go look at, did I do it for patient type? I think I did. Yes, I did. So what I came up with is in Hot Chocolate, the way that we generate the schema, and maybe I should back up just a little bit for Chad and Dave. So the Hot Chocolate framework is what we're using to create the GraphQL interface. It has the ability to look at like a plain old class object and like introspect it and generate a schema. So if you go and look at the editor that we were just looking at over here, I can switch to the Schema Reference, and it like pumps out a list of like, well, here's all the objects I know about. Here's all the queries that we have available. Is my screen still sharing?
Yep.
Good. Okay. So we get this big schema document that gets emitted by the Hot Chocolate framework, and that's what like the GraphQL interface understands to be able to know like here are the properties that are available and all the object types and everything. So like I was saying, the Hot Chocolate framework has the ability to, you pass it just like a plain old class object, and it looks at it and says, oh, cool, you've got a string, you've got a couple integers, whatever. I can generate an object for you that looks like that, no problem. The problem does come in though when we're dealing with FHIR data. It gets returned. You can see in the response of these objects, they're quite complex. And behind the scenes, what we're using is another .NET library called FHIRly, which is a whole SDK built around accessing FHIR API servers, and then it's got a whole bunch of model objects that can represent those returned responses to deal with them in code. So that's what we're using in the backend to fetch the data, but those model classes are quite complex themselves, and Hot Chocolate isn't able to automatically introspect them to generate the schema the way that we want. So the way to get around that is Hot Chocolate provides you with the ability to define your own overrides. So they've got a base class called object type, and then you wrap it or give it, the model class, if you will, or the complex type that you're trying to define a schema for. And then, that usually the nomenclature is you just name it the class name that you're trying to wrap and then add type onto the end of it. So that's how we define all of our schema for the FHIR resources that we're returning. And then it has a configure override, which is basically how you set up that schema object. And then you can choose to either extend and like add additional fields. You could override different fields. But what we're doing is we're telling it that don't automatically try to introspect anything on this object. We're going to tell you exactly what we want the schema to look like. So we say bind explicit, and then you just use the descriptor property to define all the fields that you want. And then by doing it this way, you can see like if I hover over these individual fields, this one's a string. So, okay, no problem. Like Hot Chocolate understands how to deal with primitive types. That's a string. Bing, bang, boom, no sweat. The next one on the list, oh, that's a meta resource. Meta is another model object that's coming from the FHIR SDK. So somewhere, somehow, we need to also define a schema object type extension for the meta type, right? So we get this whole big list of schema objects going over here, and that's how we correctly define the schema that will be returned by Graphir. Okay, so the other thing that I did some research on to try to solve the problem of like how do we return this list of multiple different resource reference types, there is similar to the object type extension class in Hot Chocolate, there is something called a union type. So if I scroll down a little ways here, general practitioner, that's what I'm looking for. So this is a union type, and what this gives you the ability to do is basically create a new type for your GraphQL schema that's a composition of other types. You could also use an interface. So like if you were sharing a bunch of properties between objects or something, and then you just wanted to like have your own implementation for certain properties within that type, you could do it that way. But really the only shared property across all those resources is like resource ID. So I figured the union type would be the best way to go. The other thing I've been doing in here in some cases, let's see if medication has it, is I've been putting in a description. So if you saw in the spec where it says, hey, the resource type that we're going to return is a reference to an organization, or the list of other resource types that could be returned. Like here in general practitioner, you've got org practitioner, practitioner role. I've started trying to implement these union types with a description so that in the schema document that gets emitted by GraphQL, you would see that like, oh, we're going to return a reference type here, and in the description it would say it's a reference to one of these two types of resources. Not all of them have that. I kind of just started doing that last minute. And you can see here too, like not all of the types have been implemented yet, so I had to comment out where they weren't available, and we only had like medication type for this one. So that's how I get it to basically create a reference to like, it could be these types of objects. The next thing I wanted to do is if you look at, we have some reference documents. So these are GraphQL schemas that were published by the HL7 organization that kind of dictate or define, hey, the GraphQL interface that should be implemented with a FHIR API. The schema objects should look like this when they come out. So we're using these as a reference to build up the schemas that we have in the Graphir project. So if I look, though, at how they define a reference, like we'll just pick this one as an example. It's saying it returns a reference type. That's going to be buried in like just the generic object types over here. I mean, I'm going fast because we have an hour to go through all this, and it's like a huge amount of changes. Let me scroll down and find reference. Last time I did this, I went right to it. We're getting close. Reference. So here's the reference type that the HL7 org thinks we should be emitting. It's literally just the ID, any extension properties, the reference as a string. So basically what they're saying is like, oh, in GraphQL, when you have a reference to another resource, like just pump it out like this. That's what they're saying you should do. Which in my opinion is kind of worthless. It's like GraphQL is supposed to be generating this graph of objects so that you don't have to, look at a property and say, oh, this is a link to another thing, like go make another call to fetch it. I want my GraphQL framework to do that for me. So what I did was I implemented a new resource reference class, and you can see in the example of like medication where we're using this union type up here. Where do we do that? Inside ingredient. Here we go. Oh, this one's a weird one. That's a bad example. Let me go back to patient, sorry. So inpatient general practitioner, you can see that it's a list of these items, and I'm using this resource reference type, which is now a generic. So I can wrap this resource reference type definition with like the union type that I want it to return. So I'm basically telling it like, hey, here's the union type that contains the 2 or 3 or 5 or however many different resource types that you should be referencing to. So if we go look at the definition for this guy, what I'm doing is I'm trying to make this look as close as I can, right? If you look at the descriptors here, I want it to look very similar to the HL7 org, what their definition of the spec should be. So you get, an identifier, the display name, an actual reference link, which is, again, just going to be that string link with the relative URL in it or whatever. But then what I added to it was a resource property, and this will be that generic that we passed in, right? So this will be the resource, and that's what will get returned in that call to get that object. So let's run this and do an example of it just so you can see what's going on here. May the demo gods be on my side today. All right. If you run this locally, it'll automatically spin up a local running version of the banana cake pop. You always want to look in the upper right-hand corner and make sure it says online. Basically, if that is red and says offline, it means that something went haywire with the schema generation and it wasn't able to correctly interpret your schema. And then what you want to do is like go to the logs. And you can see here we've got the call to fetch schema. But if it failed, you'll see an error message there, and it usually tells you then in the logs, like, oh, you referenced property name XYZ and we couldn't find that or whatever, and then you know where to go look and fix it. Okay, so anyways, let's look at patient. So I'll do a new one. We'll do a patient list. I can return the patient's ID. And when I'm running this locally, I'm just pointing at that happy FHIR instance. So I've got like tons and tons of demo data to work with. We'll pull the patient's name. We'll say we want their family name, their given name. Oops, given name. There we go. Let's just make sure this is working. This is a big list, so I probably shouldn't have ran on every patient. Yeah, it didn't like that. Oh, interesting. Maybe I broke it. I wanted to show you patient. Here, we'll run this one where I'm calling a specific patient and see if that one still works. So I'm trying to return the ID, their name, their birth date, and then this one has a patient link. So for the rest of the team, you guys are aware we've been kind of working on this problem where they're trying to do merge and unmerge, and the way that gets annotated or coded, I guess, into a FHIR patient record is you get a link element with a type of like replaced by or replaces. So it's basically saying, hey, this record is replaced by this other record, or this record replaces another record. That's how they handle the merges. So I've got a reference link here. Let's just see if we can get this to work. I kind of want to pull that out for a second, but let's see. Yeah, here we go. So the specific patient getter is working. You can see we return their ID, their name, their birth date, and then in the link, we've got a list of links. These are just see also links. Unfortunately, they're not replaced by or replaces links, but that's okay. link element has a type and an other. The other is the actual like reference link type. And then you can see I left in that reference, so you can always still see what the relative URL is to the resource if you choose to return that property. But then here's the new one that I added, resource, and that is returning the union type. And the query format for, I don't know, Samir, if you've ever used union types before in GraphQL, but it's a little weird with like how you have to write them. So the resource itself like doesn't just have any of the properties, right? Because since it's a union type, it could be returning, you know, any number of defined types that we gave it. So you have to use a spread operator. So you do spread and then you say on, and then it'll recognize at that point, like, hey, here's the list of types that I know about that should be returned as the union type. So you'd say like, oh, okay, well, give me the resource. And then basically, whenever that resource is a patient record, I'm saying, well, okay, on the patient records, give me these properties. If there was another type in there, I could say like, oh, on practitioner, I want you to give me a different set of properties, right? So it gives you the ability to be really flexible on exactly what properties you're returning from those different object types. So on patient, we can do name, family, and given. So now we'll update that guy. And I must have missed a closing. There we go. So now we'll run that, and you can see now within the resource, we're returning the patient's name, their last name and first name. So I think that's pretty cool so far. Like basically, I've switched up or refactored Graphir so that we can generically define resource references to like any type of resource that we want now. And if you look in the code, it's insanely easy to define those resource links. So example, general practitioner, again, was a reference to a different union type. And this is all you do. You just say, hey, it's either an individual resource reference or it's a list of resource references, and then give me basically, the type that contains the list of resource types that you want in there. This also handles the resolver for this type. So doing the lookup to go get that resource, like you don't have to add any other code into patient type to do any of that lookup. All that code is contained inside of this resource reference type for any type of resource that you want to go look up, which is really cool. So let's dive into that really quick and go look at it. Okay, so here, let's look at the resource reference type generic definition. Again, you just pass it in. I'm filtering it so that you have to pass it a union type. But here is the definition or the descriptor definition for that resource property. So I'm saying it's got to return a type of, the union type that you passed into me. And then it resolves with this resource reference resolver. So basically what this means is in the Hot Chocolate framework, if you define a field where you needed to go like look up data from someplace else, or you want to write a whole boatload of like custom logic to determine like what the value that gets returned for that specific field is, you use a resolver, and they've got these extension methods. Like you could put .resolve right in here if you wanted to, and just like put the logic in line or have it return a static value. Or you can say resolve with and point it at another class that contains methods you want to use. So basically, when I say R right here, that's an instance of this resource reference resolver class. And then on that class is a method called getResourceAsync. GetResourceAsync takes in some parameters, which also let the resolver participate in dependency injection. So like I can have services injected in here. And if I look at the code hint for that, you can see, it's taking in the parent resource. So basically, what is the parent object that this field is defined on? In our case, it will be this object type that we're saying is the resource reference type. And then it also takes in a data loader factory, which I'll show you in just a second. That's kind of another piece that I created over the weekend that gets the job done, but it seems like there might be a more elegant solution for that. But essentially, let's go and look at the implementation of this over here. So we're going to call get resource async. Again, it takes in the parent resource, and then an instance of this data loader factory, which by giving it this service attribute, that means it's being injected with dependency injection. So the first thing I do is I get a reference to the parent. So again, that's just the reference property that's coming from the parent, which includes this reference link. I put in the comments up here, technically those reference links could be a relative reference, an absolute reference, or something called an imperative reference, where they kind of like inline define the entire object in the payload. I didn't want to deal with all those. I mean, if it's an absolute reference, that basically means it's pointing to a record like in a completely different system. So I think in that case, we just don't want to return, like we don't want to try to go fetch an item from a different system, because who knows what the authentication is and that kind of stuff. So I put in the comments that we're only supporting the relative links, meaning it's got to be a link to a record in the same API. So essentially what we're doing is I'm just grabbing the reference link, which will look like this. Here's an example, patient /1234, practitioner /1234, whatever. It splits that up into the resource type and the identifier. And then I just use a switch statement to say, hey, which resource type are we looking for based on that token that came in? And then use the injected factory, which basically contains a concrete instance of all of our generic data loaders. That was something that I really struggled to get around. Like Hot Chocolate just wouldn't let me use, like at some point I had to define a concrete instance of those data loaders, otherwise it wouldn't let me use them generically. So maybe there's a better way to get around that. Hopefully, at some point in the future we could make this a little easier to deal with, but essentially right now, like this is, kind of part of the brain of the system that it just has to figure out, hey, what type of resource are you looking for based on that link? Cool, go grab the appointment by ID data loader and grab the thing. However, even though we have this monster list of, all these different data loaders, those data loaders all essentially contained the exact same code. Like it was doing the same thing, right? It's just looking up some resources based on a collection of IDs or a single ID and then returning them. So let's hop over to the data factory itself, and I'll show you how I defined those. So again, this is part of I think there could be a better way to do this condition, but it's pretty good, right? Like although we have all these different properties of, declared instances of loaders, the loader itself is completely generic. So I've got, resource by ID data loader appointment, and I'm passing in all the different resource types that I want to load with that. And then if I go look at the logic for that loader, it's really just, taking in the ID of the resource you want to look up. It uses an injected instance of the FHIR service. The search async lets you use a string to define like the endpoint or the resource type that you want to go after. And so since we're passing that in generically, and it's always like it always matches the endpoint URL in FHIR, I'm just using the name of the type T that's being implemented there to tell the FHIR client, like, here's the resource you should go get. And then it passes in the collection of IDs that you want to look up and returns them. So to get back to my earlier point of in the code base as it exists today, where you have a bunch of folders of each resource type, and in each one you have a patient by ID data loader, practitioner by ID, et cetera, et cetera. I've completely done away with all of those now. There's only one implementation of resource by ID data loader that we can use like generically for any type of resource, which makes it really easy now to add new resources in, because all you would have to do is basically come out here to the data factory, add in, like if I'm adding the group or whatever, I think that one's already in here maybe. Oh, actually, yeah, so group's already in there, but as an example, let's say I just was implementing the new schema definition for a group. I would come in here and I would add another member to the data factory, use the dependency injection to make sure we get this is basically the part that I couldn't get around with the hot chocolate framework. Like it just had to have an instance of one of these, otherwise it wouldn't let me use it generically. So you pass that in, wire it up, and then I'm just using like the Lambda syntax to return like a public getter for those members. So as a result of that, then in our resource reference resolver, that's where you see the factory, based on the determined prefix that you got, calls the correct getter, calls the load async, returns the resource. How are we doing? We got 15 minutes left. This is a whirlwind. I understand. I've made significant changes over the weekend. But it the moral of the story here is that it's going to be way easier to add resources, and it's like now we kind of have the solution for referencing resources of kind of any given type. Okay, one more kind of big change that then completes the circle on how I was able to get rid of all the individual folders for resource type, and that is we saw out here that in each of the resource type folders, you had a mutation and a query class. Side note, I guess, most of the other resources that have been implemented in the system right now only have been implementing query, not mutation. So, we completed the mutations for patient and practitioner, but those have not yet been built out for the other resources. So I've kind of left mutations alone for now, and you will still see like a patient mutation class and a practitioner mutation class. But if we look at like patient query, it's basically, this is a resolver is what it's called. It uses this attribute from Hot Chocolate where you're extending an object type. So remember, those object types are how you get the schema objects defined in GraphQL. And there's always a root query type, which is what defines like the query names that you can run. And there's always a root mutation type, which defines the list of mutations that you can run in the system. You can only have one of those, like ever. But the way that you add on to them without having like one single giant query class in your system is you use an extension or an extend object type to say, hey, on the base or the root query class that you've already defined, go ahead and add these other members as additional resolvers. So based on that, in this example, I would now get a new endpoint or a new query called patient. And we saw that over here in our example, where I was trying to call the patient list. And, I called the individual patient in my other running example. The name of that query is coming from the resolver name that's defined. Oops, I didn't mean to go back to the code yet. Right here where you're giving it the specific name, or it can get it from the method name too if you don't override it here. But if you look at like patient, practitioner, like every single resource gets implemented with a, individual item getter list of items getter. And then there's also connections, which is kind of a GraphQL thing, and we're not implementing that everywhere. So I ignored that for now. But this is pretty generic, right? And it's always like, oh, I want to add a new resource. I'm going to come into patient and copy and paste the resolver code for the queries into another class. It's like the same exact code over and over and over again. So what I did there was created a generic query resolver in the system. So if we go look at data loaders, I've got a resource resolver, which takes in a generic type of resource. And this basically does the work of either resolving an individual resource by its ID, taking in an injected instance of a generic loader. This is what's making me think that there's a much better way to do those loaders, because I am able to use a generic instance of it here. And then the get list getter down here, where it just takes in the FHIR client itself. These are pretty slick because I can just reuse the loader logic that we already had to do the individual getter, since we already have the ID coming in and loaders are designed to get resources by ID. I just kind of redirect it over to that. And then the getter just does a search on the FHIR client for all resources. Essentially, it just goes and grabs them all of that type. The way that I consume this then is
So during the rest of this recording, I describe how we use the generic resource resolvers to get rid of the individual query classes in the resource folders that we had in the project. However, it involves still writing an extension, an object type extension override within each of the schema classes that we had for the resources. So since the time of the recording, the code review that we had earlier, we've made some additional improvements and upgrades to the code base, which have been pushed at this time to the main branch out in the repo on GitHub. So now what I'd like to do is demonstrate how we were able to additionally make this more generic by creating a generic version of the query class itself, and then using that when registering the resource types with the GraphQL middleware. So here is the generic resource resolver that I was just demonstrating the code for. And now what we can do is go take a look at within the query folder, or the queries folder, excuse me, in the project, we have a generic resource query class. And this should look pretty familiar. It's essentially the same code that we had in the code first model for the queries, but this is how you would do it if you instead leveraged the object type extension class within GraphQL. So I'm overriding an object type extension of type query. Again, that's our root query class, which you only are able to register a single query class within your GraphQL middleware, and then we can extend it with additional queries or objects using this object type extension. And it's taking in two generic types. The first one is going to be the resource type itself. So that would be the model class coming from the Firely.net models namespace. And then the second is going to be the object type, or the schema type that we've defined for that resource. So as an example, if I were going to implement this for a new object type that we're writing. So say I needed to build out the condition resource. We didn't have that yet in the system. So I would first go to my schema and I would create a new class for the condition type. You can see this has already been built out. This is exactly what we've seen before, where you bind all of the fields explicitly and then define exactly what you want this object to look like. So we're building up our schema here. Then what I need to do is register this new object with our GraphQL middleware in the startup. So I would create a startup.condition.cs file. And if we look in here, this is similar to all the other ones we've just seen. We've got the graph builder itself. So, you know, we can chain the startup here to the different classes by taking in a reference to the graph builder itself. This is just a standard extension method syntax here. So on the graph builder, then we're going to add the data loader for our new condition class. So this is the generic data loader, how we register that with the startup and the middleware. And then right here, we're going to add a type extension. So instead of adding a type extension and giving it a class like we had before for each of the resources that contain the queries, now we can register this generic resource query, pass in the model class that we want it to consume, and then the condition type or the schema that it will be returning data for. So once we complete that, finally we just add the schema type itself in, and then we should be able to run this. And that will load up. It'll just take a second. So there we go. The schema has loaded. If I go and look at our schema reference, and I look in our list of queries, I should now see, if I search for a condition, we have a condition query, or excuse me, this is the condition object. Let me go back to the queries themselves here. So if we look at the list of queries, we have the condition, which is the individual getter for our conditions, and then we have the condition list endpoint. Let's hop over to our operations, and we'll do a new sample query here. We'll look for the condition list. We'll pull back the ID, and let's see if maybe we can look at the code for the condition. Drill into the coding, and we'll look at the display name if there is one. All right, so let's try to run that and get a list of conditions. And there we go. We've got several of those in our sample system, and you can see them listed here. All right, so this concludes the code review recording and also this video. We're really pleased about the upgrades and the changes that we've made to Project Graphir. We think, again, that this will be tremendously valuable and much easier to define additional types. Thank you so much for watching this video. We hope you get some value out of using our Project Graphir, and you use this as an example of how to enable a lightweight GraphQL proxy over FHIR data. Thank you.